Have you ever noticed repeating patterns in things like ferns or clouds? Today, we will explore fractals, which are infinitely complex patterns. We will learn about self-similarity and iteration using famous examples. A fractal is a shape that contains detailed structure no matter how closely you zoom in. This unique property, called self-similarity, means that small parts look exactly like the whole shape. Fractals are built through iteration, which means repeating a simple rule over and over again. Let's look at the Sierpinski Triangle, a classic fractal shape. You start with one large triangle, remove the middle section, and repeat this rule for all new smaller triangles. Even the smallest remaining parts clearly resemble the original large triangle. Another famous example is the Mandelbrot set, generated by a complex repeating equation. The boundary of the Mandelbrot set shows astonishing, beautiful detail when you zoom into it. These shapes exist between our normal dimensions, giving them a fractional dimension. They are too complex to be a simple two-dimensional surface but not fully three-dimensional either. We see this same complexity in nature everywhere we look. Coastlines, tree branches, river systems, and even blood vessels are natural fractals. Imagine you are drawing a simple tree using a basic fractal rule. First, draw a trunk, and then split it into two smaller branches at the top. Next, you repeat the split on each new branch, making them smaller each time. Continuing this process generates a realistic, self-similar tree structure. Notice how iteration allows a simple rule to create vast complexity. We learned that fractals are self-similar, complex patterns built by repeating simple iterations. Examples like the Mandelbrot set show how these fascinating shapes possess fractional dimensions. Look closely at the patterns around you and recognize the infinite beauty of math in our world. Generate your own educational videos for free at eduvids.vercel.app.